Hello student. This is the fourth part and the last part of your rolling contact bearings, and we were discussing in the part 3 this numerical, and we will cover this numerical in the fourth part, that is last part of this video. So let's see the statement again. A shaft rotating at constant speed is subjected to variable load. Bearings supporting the shafts are subjected to stationary equivalent radial load 3 kilonewton for 10% of the time, 2 kilonewton for 20% of the time, 1 kilonewton for 30% of the time, and no load for remaining time of the cycle. So we will give the write the given data. 3 kilonewton for 10%, that is 0.1 of total time. Total time, let's say n. 2 kilonewton for 20% of the total time, 1 kilonewton for 30% of the total time, and zero load for the remaining, that is 40% remaining of the total time. Another thing given to us is total life expected for bearing is 20 into 10 raised to power 6 revolutions at 95% reliability. So L95 is 20 into 10 raised to power 6 revolutions. Let L90 is equal to life of the bearing corresponding to reliability of 90%. So if your reliability is 90%, we write the life of the bearing as L90. L95 is the life of the bearing corresponding to reliability of 95%, which is given to us 20 into 10 to the power 6 revolutions. So as we have discussed the formula given by Weibull, that is L by L90 is equal to log 1 by R divided by log 1 by R90 raised to power 1 by B, where B is 1.17. We apply this formula. L95 by L90 log 1 by R95 log 1 by R90 raised to power 1 by B. B is 1.17. So we put the value of R95, that is 95%, 0.95, and R90, that is 90%, 0.90, and calculate the ratio L95 by L90. And since L95 is given to us 20 into 10 raised to power 6 revolutions, so we can calculate L90, that is 37 into 10 raised to power 6 revolutions. So we have calculated life of the bearing corresponding to 90% reliability. Why we have calculated? Because we have to find C, and in the formula of C we write WL90 by 10 raised to power 6, 1 raised to 1 by K. So L90 we have to find, but we have not given the value of N90, we have given the value of L95. So from L95 we have calculated L90 so that we can put in the formula of C. Now the only thing remaining is to calculate W. So W is equivalent radial load, and its formula we have discussed in the third part. W is equal to N1 W1 cube, cube is K, K is 3 for the ball bearing, N2 W2 cube plus N3 W3 cube divided by N1 plus N2 plus N3 raised to power 1 by K, that is 1 by 3. So put the value of N1 0.1 N, W1 is 3, N2 0.2 N, W2 is 2, W3 0.3 into N, and W3 1, W4 is 0. So this thing will be 0 divided by N1, N2, N3, N4. and raised to power 1 by 3. From this, we will calculate W, that is equivalent radial load is 1.663 kilonewton. And now we can easily calculate, we have to find dynamic load rating, that is C is W into L90 by 10 raised to power 6 raised to power 1 by K. Put the value of W, L90 and K, and your answer is 5.54 kilonewton. So this completes this question. So guys, practice more and more questions from rolling contact bearings so that you can solve it easily. Thank you guys.